Okay.
I've heard that before.
So,
Uh-oh, I forgot to make an exit code.
Oh, yes.
okay, so what I want to give you guys is recursion today. And to do recursion, I want to think up an example. The easiest example I could think of was factorial from math class. So, you guys know how factorials work? You know this symbol?
Yeah, you seem so angry.
So if you had, like, say, 6 factorial, what would you do?
1 times 2 times 3 times 4 times 5.
I mean, you could drop the one, but
Yeah, so I think maybe let me arrange that the other order.
Sure.
So we do, not starting with 5, but starting with
6.
6. So we do 6 times 5 times 4 times 3 times 2 times 1. And then when we get to 1, we stop, right? Yes? So since I'm thinking about this in computer coding land, I really should probably think about some kind of pseudocode, right? So what sort of thing is this going to take? Like if I wanted to talk about the factorial function, right? It's going to take
Or a string. Or some kind of numbers.
And it's probably.
Think
integer.
specifically, if I'm going to go down by ones, right?
Right.
I'm probably talking about an integer. If I'm going to go down by ones and stop when I get to 1, what would you do with like -2? You tried -2 factorial?
Isn't
How would that procedure work?
Go up towards 1. Or up towards -1, I guess.
Yeah, basically, I don't know. So I'd kind of disallow that, right?
Oh, natural numbers.
Yeah, so these should be just natural numbers. You could maybe get away with defining 0 factorial as 1. That might be a reasonable definition to make for math reasons. But in this class, I'm also going to pitch that idea. Okay? Maybe in math class we'd do that. In math class we probably wouldn't do this.
So if n is greater than 0,
So
Yeah,
n
so
is integer.
I really want to take a positive integer, right? Like maybe a strictly positive integer, meaning that it better be 1 or bigger. Right? You guys with me on that?
Yeah.
Okay. And what am I going to do?
Take that number.
multiply a current number.
Yeah, I'm going to sort of like take the number I'm at, check it against 1, right? Like see if I'm done. If I'm not done, then what's all this stuff right here? Like what's 5 times 4 times 3 times 2 times 1? If you just ignored the 6, what's that?
5 factorial.
That's 5 factorial, right? You guys see that? Like this whole object here is 5 factorial. What's that whole object there? The 4, 3, 2, 1? That's 4 factorial, right? And then this stuff in here,
3 factorial.
and this part here,
2 factorial.
that's 2 factorial, and then this part's 1, right?
0 factorial.
Which is, yeah, it's 0 factorial. So I think what I'm coming up with is that n factorial is n times n minus 1 factorial, right? And then the only one I actually need to tell you how to calculate is 1. All the rest are just made out of this bit. You guys see that? So I think my pseudocode would be something like, takes a strictly positive integer. If that's 1, return. What's the answer for 1 factorial? 1. If not, right, else. Else what? Right, so what are you going to return? Take your number you're at, right? So I'm going to call my strictly positive integer n, right?
It is 1
n times, not n minus 1, but n minus 1
Factorial.
factorial.
Alright.
You guys see that? So what this thing's going to do is it's going to call itself a bunch of times. And then when it gets to 1, it's going to stop. You see that? So if I put 6 in, right? Like if I do factorial of 6, the very first thing that's going to do me is it's going to run through here. So it's going to say, okay, 6 is a positive integer. Is that positive integer 1? Is 6 1?
No.
No. So then it's going to return 6 times factorial of 6 minus 1 is 5, right? And then it's going to pass 5 to the factorial function. So is 5 1?
No.
No. So then it's going to return 6 times 5 times factorial
4.
of 4. Right? And then it's going to check 4 against 1. And it's going to return 6 times 5 times 4 times factorial of 3, and so on, right? Until we get to 1, and then we're going to stop. And then we're going to know what we got out of the factorial function. You guys see this?
We make a class called Factorial and have it do some stuff to things.
Yeah, we could, but you probably don't need a whole class, right? You just want to do factorial to numbers, right?
Right.
Factorial itself shouldn't possess any attributes. Like, factorial doesn't have any variables associated to it. It just takes a variable and returns a variable.
Okay.
So this is a good example of what I would call a spot where you just need a function. Right? This doesn't need to be an object. It doesn't need to have properties or methods that it does. This is just going to be some method in processing, or in Python, this would literally just be a function. You guys cool with that? What's the difference between a function and a method? How is a function different than a method? It's maybe easier by thinking about where does a method live.
In front of.
No, a method lives in.
The coding of.
It lives in coding land. Good, that's a start. It lives in a specific kind of thing in coding land. Ben, you want to remind them?
So all processing is methods because it's all stacked into the processing
That.
class
Object.
or object. Yeah.
Yeah, so a method is a property of an object, right? It lives in a class. You define it for a class, and then the only way you can get at that thing is to have an object that's a member of that class and enact that thing on it. You guys see that? This object here, right? The kind of idea of factorial is not itself a programming object because it doesn't need any properties, right? The only reason it's a method in processing is that processing is itself an object, right? In Python, this thing would just be straight up a function. You guys want to try coding in both languages?
Yeah.
Cool.
Really?